Hi there and welcome. My name is Rebecca Weaver and we're looking at section 6.2 today, the definite integral and net change of a function. So we'll start with the definition of the definite integral. Suppose that f is a continuous function on an interval, it's a closed interval, a to b, with an antiderivative, capital F, that is, capital F prime of x equals f of x. The definite integral of f from a to b is the integral, and you will evaluate this from a to b of f of x dx. This is going to be equal to capital F of b minus capital F of a. The numbers a and b are called the limits of integration, with a being the lower limit and b being the upper limit. The number capital F of b minus capital F of a is the net change of the function f as x varies from a to b, and is abbreviated by the symbol capital F of x evaluated from a to b. So let's do one of these. We need to evaluate the integral from 1 to 2 of x dx. So we need the antiderivative of our f of x. So capital F of x is 1/2 x squared plus c. So from number 1, which was our definition, we're just going to substitute in our 2, and then we're going to substitute in our 1, and then we'll just subtract those two numbers. Notice that the c becomes irrelevant because it will be a c minus whatever that constant is. And so you'll just get those two numbers, and that will end up being 2 minus 1/2, which is 3/2. So if we let f of x and g of x be functions, and a, b, and k be any constants, then if we have a sum of two functions, f and g, and we're evaluating the integral from a to b, we can just separate that integral and evaluate from a to b the integral of f of x dx and the integral from a to b of g of x dx. Same thing with subtraction. Very similar, you just same thing with the constant, you just pull that constant out. Something of interest is if we're evaluating an integral from a to b, and instead we want to evaluate it from b to a, we would find that it would just be the negative of that answer. If we evaluate a function from a to a, that answer will just be 0. If we evaluate an integral from a to c and from c to b, it would be the same thing as doing the integral from a to b of f of x. So let's use some of these properties. We're given that the integral from 0 to 6 of f of x dx is 8, and the integral from 5 to 6 of f of x dx is 7. So we need to find the integral from 0 to 5 of f of x dx. Now by number 7, we can look at this and say, oh, we can just put these two together and write them down as a sum, and we can find out that if all I need to do is just insert for the integral from 0 to 6, that answer was what, 8, so put in an 8 for that one. And then we have our sum, the integral from 0 to 5 of f of x dx plus that other integral was 7. So just solve that, and we get that that integral that was missing, the integral from 0 to 5 f of x dx is 1. Cool. In the definition of the definite integral, since little f equals capital F, we can write number 1 as the integral from a to b of f prime of x dx equals capital F of b minus capital F of a. Now recall that the derivative of f prime is the rate of change of f. Thus, by number 8, it states that the integral of the rate of change of f is its net change as x varies from a to b. And that's all we have on this one. We're just going to be substituting in those numbers and crunching out from our antiderivatives or our integrals. If you have any questions, be sure and email me, rweaver10@alaska.edu. Have a wonderful day.